So you've probably seen someone pop a wheelie and thought, whoa, how does that even work? Today we will be diving surprisingly deep into the physics of the most iconic bike trick ever, the wheelie. Hey everyone, I'm Jonathan, and this is your crash course in how physics makes wheelies possible. Spoiler alert, it's a lot more than just yanking the handlebars. Center of mass will be right there in the middle of the bike. Let's start with the basics. When you're just riding normally, your weight, or more precisely, your center of mass, sits somewhere around your belly button, right over the bike's frame. The center of mass creates a force, or a gravity, pulling you straight down, and now the key to a wheelie is shifting that force backwards so that it lifts the front wheel. To do that, you shift your body back and pull the handlebars up. You're essentially rotating your weight around the rear axle or your pivot point. This creates something called torque. Torque is a rotational force. If you've ever used a wrench, you're already familiar with it. When your center of mass moves behind the rear axle, gravity starts creating torque that wants you to tip backwards. Torque will be applied to the ground on the bottom and on the pedals right here going around. Think of it like this. The rear axle is the pivot, your body weight is the force, and the distance from the wheel or from the axle is your leverage. The further back you lean, the more torque you generate to lift the front wheel. But too much torque, and boom, you're going back. So the real trick is balancing your torque with another force, which is acceleration. Think about it like this is the front wheel and this is the back wheel. As you're going back, the front wheel is still applying force going forward. So you have to balance that out with acceleration. As you pedal, the rear wheel pushes the ground backwards thanks to Newton's third law. For every action, there's an equal and opposite reaction. The ground pushes forward on the bike. That forward push gives you acceleration. So now you're working with two things: backward torque from your weight and force torque from pedaling. The wheelie happens when these two forces are in just the right balance. At the magic point that we call the balance point, your rotational torque exactly matches your forward acceleration. You're not tipping backwards, you're just floating. There is a catch though. You'll never stay perfectly balanced. Your body will always be making little control adjustments, leaning forward or back, changing your pedal pressure to stay in control. This is where braking comes in. Light taps on the rear brake reduce your speed just enough to shift your balance forward if you're not tipping too far back. This is like a tightrope walk, but with your body, and the bike is consistently communicating. It's all about dynamic balance, a consistently shifting sweet spot between gravity, acceleration, and rotation. Okay, real quick, let's break it into steps so that you can visualize the process. The first step is start in a low gear. You want a smooth power, not a jolt. 2, pedal and pull up. Shift your weight back and generate that torque. 3, find your balance point. Use your body and brake to stabilize. 4, keep pedaling. Steady cadence keeps forward motion and balance. And 5, adjust constantly. Tiny tweaks in position and brake. Use that to keep you upright. Different bikes will feel different. A BMX, for example, has a short wheelbase, so it pops up easier, but it's twitchier. A mountain bike is more stable, but heavier. The physics are the same, but the feel takes practice. So next time you see someone cruising on one wheel, remember, they're not just showing off, they're performing a complex balancing act of forces, torque, and motion that's physics in action. Once you get it dialed, it feels like you're flying. Just you, your bike, and gravity in perfect harmony. Thank you for watching, ride safe, and see you next time.